In this video, I'm going to explain how to do problem numbers 6, 14, and 22 from the usub worksheet. Starting with number 6, usub, we're going to let u, we don't have very many choices here, we're going to let u equal 8x minus 1, and then that means that du is equal to 8 dx. Okay. Well, we don't see an 8 dx. However, we do see, let me rewrite this as 1 over 8x minus 1 to the third power and then dx. Okay? So if we divide both sides by 8, divide both sides by 8, this equation down here, we get 1/8 du is equal to dx. So we can see that in place of this dx, we're going to replace it with 1/8 du, and then we're going to replace our 8x minus 1 with u. Okay, so we have 1 over u cubed times 1 over 8 du, which if we factor out that 1/8 and then rewrite our integrand, we get 1/8 times u to the negative 3 du. Well, we have a formula for that, and the formula is 1/8, so we have 1/8 multiplied by u to the negative 3 plus 1 over negative 3 plus 1, and then that's plus c. So our formula is just the power rule. When we have any variable to a power, we add 1 to the power and we divide by that number. And let's see, this negative 3 plus 1, that's going to be negative 2 there and negative 2 there. And it does get a little bit messy when you show every little step, but nevertheless, we have negative 1 over 16 multiplied by u to the negative 2, or 1 over u squared, plus c. So I would actually write that, I was going to write it with negative 1 over 16u squared, but the u is 8x minus 1, so we have to make sure we put that in there. So we have negative 1 over 16 times the quantity 8x, that's not a good 8, 8x minus 1 squared plus c. And that's it. Just have to be careful with when you're moving around fractions, and then when you have when you use the power rule and you have negative exponents and then dividing by a negative number, it gets a little tricky as well. So hopefully that helps. Now number 14, this is probably the most difficult of the three, in my opinion. We're going to let u equal x minus 4. Normally if we have a grouping symbol like the square root symbol, or I guess any kind of like absolute value or anything like that, we're going to let u equal what's inside. Okay, something being raised to a power, we're going to let u equal what's inside. So, but notice that our du equaling dx, we didn't get rid of our x squared. Okay, so what in the world do we do with that? Well, we take this first equation and we solve for x, so we get u plus 4 is equal to x. So therefore, x squared is going to equal u plus 4 squared. So for converting everything to u's and du's, we have to get rid of the x's. So no x's and u's in the same integrand. So we end up with the integral of, now again, x squared is u plus 4 squared, and then that's all over u to the 1/2. Sorry, I was almost going to put negative 1/2, but it's u to the 1/2. And then the du is the dx, so in place of dx we put du. Now it still doesn't look very good, but we're going to move things around a little bit. Okay, and we're going to multiply out the numerator, so we get u squared plus 8u plus 16. Okay, and then we're going to rewrite that u to the 1/2 in the denominator as u to the negative 1/2 in the numerator, And it's pretty rare you'd have to do something like this, but nevertheless, it's just an extra tool in your toolbox. Now we're going to multiply out the u to the negative 2. We're going to distribute it to all three of these terms inside the parentheses. Okay, so we just have to make sure we're careful about our laws of exponents. So we have u to the 2 times u to the negative 1 half. So we have 4 halves. I'm going to do this in 2 steps. So we have u to the 4 halves minus 1 half, okay, plus 8u to the 2 halves minus 1 half, okay, and then plus 16u to the negative 1 half. Okay, so that's all still the integrand, okay, and then let's see, 4 halves minus 1 half is 3 halves, so we have u to the 3 halves, plus 8 times u, 2 halves minus 1 half is 1 half, and then plus 16u to the negative 1 over 2. Okay, so now we're ready to use our power rule, and you probably can finish it up on your own, but, oops, I don't need that. Our antiderivative of u to the 3 halves is u to the 5 halves, so 3 halves plus 1, 3 halves plus 2 halves is 5 halves, divide by 5 halves, or we can do that in one step, multiply by 2/5. Okay, plus 8 times, I'm going to put the u to the 1 half plus 1 is 3 halves, divide by 3 halves, or multiply by 2/3. That's why I left a little space there. Okay, plus 16, again we're going to leave a little space there, because we know we're going to have a fraction. U to the negative 1 half plus 1 half, that's 1 half, and then divide by 1 half or multiply by 2, and then we have a plus c. Okay, so what if we brought this all the way back up here? Okay, and let's simplify things a little bit and bring our substitute our x minus 4 back in for u. So we have 2/5. We have 2/5 times u, which is x minus 4, and that gets raised to the 5 halves power. Okay, and then we have a plus 16/3, plus 16/3. The problem with these kinds of problems is there's just so many places where you can make a mistake, and I may have already made one. I'm always leery about these. U to the 3 halves, and that's x minus 4 again. X minus 4 to the 3 halves. Can I squeeze it all in? And then plus 32 times the square root of x minus 4, and then plus c. And there you go. That's it. Put a big box around that. And that is it. You're most likely never going to have to do a problem like that on the AP exam, because it's just a lot of work. Okay, and usually the problems that you get on the AP exam don't require that much work, but it's definitely a good problem to do so that you can just go through the exercise of finding an antiderivative being with all those fractions. Okay, so number 22 here we see something that screams at me here is just that we have a function 4 minus cosine x, and we also have the derivative of that function sine x dx. Okay, so that's what I'm going to let u equal. I'm going to let u equal the function 4 minus cosine x. Okay, so what I said in the last problem, I said, look, let u equal the part of this integrand that's either under a square root or being raised to a power, like a fractional power, or like in problem 22 here, we can see the power of 3, so we let what's inside be what u is equal to. So that's kind of like the thing you want to look for. Is something being raised to a power, and if so, do we have that something's derivative in the integrand? And yes, we do. Like I said, we have sine x dx, which is the derivative of cosine, and I know that there could be a minus sign difference, but that's okay. We can handle it if the difference is only a constant. All right, so let's keep going. We have u equaling 4 minus cosine x, and du then would be The derivative of the cosine is negative sine, so the derivative of negative cosine would be sine. Okay, so we have sine x dx, and that's in fact what we have here. So that's good, because in place of the sine x dx, we're going to put du. Okay, so we have the integral of du, because we have that sine x dx in there. And then we have u to the third power in our denominator. And so we can rewrite that as u to the negative 3 du. And we just apply our knowledge of antiderivatives of some function to a power. And that means that we take the power and we add 1. So negative 3 plus 1 is negative 2. And we divide by that number. Okay, and then we add c. So we can bring the negative 1/2 out here. And then we can write the u. Remember, the u is 4 minus cosine x. So 4 minus cosine x to the negative 2, and then plus c. Now, you could leave it like that, but if this were a multiple choice problem, that probably would not be the form that you'd see that answer in. More than likely, you'd see it as negative out here, and you'd have 1 over 2 times the quantity, 4 minus the cosine of x to the second power, and then don't forget the plus c. And that's it.